Let us discuss free body diagram. As the name suggests, free body diagram refers to, like, I am taking an object, I am freeing it from an environment, and then I am analyzing the forces that is acting on that object. Let me repeat. So what is free body diagram? From the name itself you can see I am freeing a body from an environment, then I am analyzing the forces that is acting on that object if it was placed in that particular environment. Okay, so what are the forces that we come across in this free body diagram concept? Okay, let us see. The first one is weight, second one normal force, also called as normal reaction force, third one is frictional force, fourth one tension, fifth one elastic, spring force. We'll discuss each force individually. Let's see what is weight. We all know that gravitational force is experienced by every object on earth. So what is weight? Weight basically refers to the force with which an object is pulled towards to the earth. So let me take an object M of mass M. So what would be the weight of this object? It's very simple. This object is pulled towards to the earth with an acceleration due to gravity of g. So weight of this object is mg. The concept of weight is very simple. It's basically the gravitational force. What is weight? Weight is the force with which an object is pulled towards to the center of the earth. Okay, so what is the next force? Now we need to understand a point here. This normal force and frictional force are actually contact forces. They come into the picture when they are in contact, when objects are in contact. Now let me get into the normal force. What is normal force? Now let's take, I'm placing a platform here and I am placing an object M. Now we need to understand that when object is placed on a platform, object M exerts a force. What is the force it exerts? It is mg. What is mg? Weight of the object. So what is normal force? Normal force tells you that it is a force that comes into play when two objects are in contact. To be precise, normal force refers to the component of contact force that is perpendicular to the surface. I'll repeat. What is normal force? Normal force is the contact force that is perpendicular to the surface of contact. So what does it mean? So I have an object, I have placed it on a platform. So what it says, normal force is the contact force that is perpendicular to the surface of contact. So what is the contact force? So you see, I have an object M, I placed it on a platform. So what is the contact force that is perpendicular to surface? So I can write this as N. That is normal force. So you can see there is so we call this as action reaction pair. That is, I place an object on a platform. What happens? It exerts a force. Due to the gravity, it becomes mg. You can see a force going in the downward direction, that is mg. So when it exerts a force, when the block M exerts a force mg, what happens? There is a reaction. What is that reaction? That reaction is like the contact force that is perpendicular to the surface of contact. You can see what is perpendicular to the surface of contact here? The perpendicular surface of contact is in this direction. So you can see there is an important point here. I have an M, it exerts a force mg. You have a platform. What happens? It's as a reaction. When mg exerts a force on this platform, what happens? There is a reaction, and that reaction is called as normal force. And what is that normal force? The contact force that is perpendicular to the surface of contact is called as normal force. Now let's take different cases to understand how it works. Now let me take an example. Let's take a ladder is placed. Let's say this is point A, this is point B. Now what would be this normal force here? Let's take this is surface. What is the definition? The contact force that is perpendicular to the surface of contact. Normal force is what? The contact force that is perpendicular to the surface of contact. Now here you see I have a ladder, I have placed it on a wall. Now this is the point A. Now what would be the normal force here? It would be in this direction. Why am I writing this direction? You can see this is 90 degrees. And what would be the normal force here? It would be in this direction, NB, that is 90 degrees. I repeat, what is normal force? The contact force that is the component of the contact force. I would write to say the component of the contact force that is perpendicular to the surface of contact. So what is the component here? So you have NA, NB. Okay. Now let's take one more interesting example. In this case, how do you define? So let's take, I have an object here. So how do you define this? So you can see what would be the contact force. So here this is a point. Now the normal force would be in this direction. You can see this. This is NA and here it would be NB. Okay. Now let me take one more example. It would be very interesting. Okay, let's take, I have a block here. Now what would be the normal force here? It would be, now it's very interesting. Now here I can directly write NA, but here I need to resolve into two components, that is, this is NY, NX. Okay, the normal force at this point is NY in this direction and NX in this direction. We need to know that NY and NX are independent, that is normal force in Y and normal force in X are independent. I repeat the concept. So what am I doing here? In this surface, it is NA is here, it's perpendicular. You can take a perpendicular here. Here, what is the perpendicular I am taking? I am taking here. There are two, I am resolving into two components, NX, NY. You need to remember this thing. Okay. Now next point that I am going to discuss is, like, let's take another example. So let's take, I have a surface, I have a smooth inclined plane. Okay. Now we'll get back to the free body diagram. Anyway, I have a M. This is on a slope. Now how do you resolve? You know that mg, let's take this is theta. Now this is what? This is g. Now what would be this? Let me resolve into, this is theta. So you can see if I take a component onto it, what do I get? This is this value turns out to be, if I take, this is g. What is the adjacent side here? Let's take a, we can resolve into like a right angle triangle. Okay. Now here what do I get? This is g and this will turn out to be g cos theta and this would be g sin theta. I am resolving into two components. Okay. This is g cos theta. Now what would be the normal reaction here? The normal reaction would be here n. So this is m. So n would be mg cos theta. Now let me discuss what is free body diagram. So since we have got a basic idea of this concept, let's see what is free body diagram. Now as when I began the class, I have told you that free body diagram is basically I take a body from an environment, then I am analyzing the forces acting on it. Now for the purpose of example, let me take this body. Let me take a small example here. So I have a platform. Now let me take individually, let me draw the free body diagram for this particular platform. So how do I do that? Let's do it. So I take this M and I take platform. Okay, what am I doing? I'm circling it out. See what am I trying to do? I'm trying to draw the free body diagram of this particular system. So what is the system? You have one M and you have one plank or one base. So there are two objects here. One is M and one is just base. So I just segregated, I just isolated it. Now after isolation, I am trying to find out the forces acting on it. Now we know that what is the force acting here? It is mg. Okay. And what would be the normal reaction here? This would be N. Are you getting it? So basically what am I doing in free body diagram? I am actually segregating it. I am isolating it. and I am analyzing the forces independently. See, this is a system we have M and mg, M and one Planck. Then I am isolating it, I am segregating it into two components, M and this particular Planck. Then what am I doing? Then I am trying to find out the force acting on it. We know that mg force is acting downwards and n is acting upwards. That is a normal reaction. So this can be said as action reaction pair. Okay, it's very simple, it's not difficult. So this is something I would like to tell you. So basically what do I do in free body diagram? I segregate two objects, then I analyze the forces acting individually on it. We'll be doing more problems in the coming videos. Anyway, for the purpose of explanation, I am telling you, I segregate two objects, then I analyze the forces acting on them. Next is frictional force. Frictional force is very simple. Let's take an example. Anyway, we'll be discussing in the next chapter in detail about friction. Anyway, for the purpose of example, let's take, I have an object. What is frictional force? So this is M. So if I apply a force F, then what do I get? There will be an opposition force. So this is like I can write it as, let me write it as mg, and this normal reaction is N. So what do I understand from frictional force? Frictional force comes into play when objects are tangentially, like in contact. When two objects are in contact, when it moves tangentially, it acts in the tangential. That means normal reaction is what? It acts perpendicularly. Frictional forces, it acts tangentially. Keep this in mind. So what is the difference between normal force and frictional force? Both are contact forces. Here normal force comes into play when they are perpendicular. The component of the contact force that is perpendicular to the surface. Meanwhile, frictional force is the component of the contact force that is tangential to the surface of contact. Anyway, I will be discussing it in detail in the next chapter. Just for the purpose of the explanation I am giving you. So what is the difference between normal force? Normal force comes into play when two surfaces are in contact and it is perpendicular. That is the component of the contact force that is perpendicular to the surface. Meanwhile, when does friction force comes into play? Friction force comes into play when the two objects are in contact and it is tangential. It is tangential. You can see normal reaction is perpendicular, frictional force is tangential. Anyway, let me discuss the next concept, that is tension. Let's discuss tension force. So what is tension force? Tension force is an intermolecular force that exists in a string. So let's see what is the scenario for this. So I'll give an example for that. Let me take a block of M, mass M, and I am trying to pull it. I am trying to pull this block. So this point A, B. Now what did I say? I am saying that tension force comes into picture when you pull any object with a string, or any object is connected to a string. So there are certain conditions that we take into consideration while discussing this concept. The string is massless, frictionless. These are the main two conditions, and one more thing is it is inextensible. The string that we take into consideration in our discussion while discussing the tension force is that it is massless, frictionless and inextensible, that it cannot be extended. So I have a string here. Now what do? I want to find the direction of the tension. So you need to understand that when tension acts in a way from opposite to the point of contact. I'll help you understand it. So I am pulling an object. Now what is the direction of force with respect to point B? It would be in this direction, tension. Okay. And what about this? I am pulling an object of mass M connected at A. Now what would be the tension experienced with respect to A? It would be in this direction, T. You can see it is moving away. So if I pull a log, what happens? I am pulling it with a particular force and the tension would be acting in the opposite direction. That is, when I am pulling a mass M, what is the tension with respect to B? It would be in this direction, opposite to it. Now let me give an example of a pulley to explain the free body diagram of this particular tension force. Okay, so what do? let me draw an image here. Okay, I'll give a pulley problem to explain it. This is one, this is P1, P2. Let's take this as some, okay, string 1, this is string 2, this is let's take this as mass 1, mass 2, and this is connected with string 3. Now what am I trying to do? I have a pulley system, pulley and mass system. Now I am trying to calculate the free body diagram. Now you will be able to understand what exactly free body diagram here is. Now what did I say before the start of the class? I said that this free body diagram helps you to isolate an object. What is the object here? Let's take, there are 4 objects, P1, P2, M1, M2. I isolate an object from this system. This is a system. You have 4 objects, P1, P2, M1, M2, pulley 1, pulley 2, M1, mass 1, mass 2. So how do I do this in free body diagram? I isolate an object, then I look at the forces acting on it. Let's do it. Let's do it. So you have P1 pulley, this is P1 pulley, and this is P2 pulley, M1 mass, pulley 1, pulley 2, mass 1, M2 mass 2. So what am I doing? I am trying to calculate the free body diagram. So let's take individually each one. P1 I take. Now you can see the direction. This is like this. This is like this, like this. Okay. Now what did I say? The string that I am taking into consideration is massless, frictionless, inextensible. So you need to understand that this is one string. The string is the same, red string. This is blue string. This is green string. So you need to understand the point that when the string is massless and frictionless, the tension would be the same. I'll repeat here. So let's say this is T, this is T2, this is T2. Why am I drawing the directions in this direction, downward direction? Because as I've said that this M1, M2, the tension experienced by P1 would be acting in this direction due to these two, M1 and M2 and pulley 2. How about this? Since this pulley 1 is connected to the roof, it would be acting, let's take it as T1. You can see the tension or the tension force acting on pulley 1. What am I doing here? I am trying to calculate the free body diagram. I am trying to draw the free body diagram. I am trying to draw the free body diagram. How do I do that? Let's do it. So I have P1. So T2, T2. What is T2, T2? They are acting away. They are going downwards. Okay. And string 1, they are going upwards. T1. Now how about this M1? It is connected to P2. So what will be the direction of T? This is T2. Now you may ask a question, how did this be T2 and this be T2? Anyway, I'll get back to it. Now this is what? This is M1G. Okay, I'm telling about the forces acting individually on M1, P1. What is this? This is called as free body diagram. I take an object, I place it, I isolate it, then I am trying to calculate the forces acting on it. So T1, this is T1, this is T2, 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 and this is also T2. Why is it T2? Because you see the string is the same. When the string is massless and frictionless, then the string will have the same tension. I repeat, when the string is massless and frictionless, what is it? This is the blue string. The blue string will have the same tension. So I am writing the same value T2, T2, and here I am telling T1. Why? Because red string is different from blue string and green string is different from blue string. Okay. Now let's draw the free body diagram of P2. P2. So how is it? It's something like this. So this is what? This is T2. This is T2. You can see this, it goes away, the tension, it goes away. With respect to this is T2. For pulley 2, the tension are T2, T2. So here what happens? This is T, 3. Now you can see T1 is what? T1 is the tension for string 1. T2 is the tension I am indicating for string 2, and T3 the string I am using T3. Now let's take this M2. Now let's see the free forces acting on it. This is T3, this is M2G. Now I'll repeat this once again. So what am I doing? I took an example of a system, pulley system, P1, P2, M1, M2. I have 3 strings, string 1, string 2, string 3. You need to understand that all the strings that I am taking into consideration are massless and frictionless. So one condition we need to note that when a string is massless and frictionless, the tension would be the same. So the tension of string 1 I am writing it as T1, of string 2 T2, of string 3 T3. I am writing it as T3. So how did I do that? I take an individual object, I took it P1. What are the tension? You can see it is acting away. It is going away. See what did I say? Tension always acts away from the point. So the point of discussion is what? P1. Up, like you have a tension in the upward direction, it is moving away. 2 tension, that is going downwards. Why I am writing T2 because they are of the same string. Okay. Now how about M1? M1 has a string connected to P1. So since the string is the same, the tension is all the same. But why am I writing upwards for T2? Because you see tension always go away from the point of concern. So the point of discussion is what? The object that is considered is M1. So tension always goes away from the object. So it is T2, and here what is this M1? M1G is a weight that is acting downwards. Now let's see P2. P2 you can see it is connected through a string 3. So you can see T2, T2. You can see T2, T2. Why is T2 acting upwards? Because tension always goes away from the point that I am taking into consideration. Okay. So here you can see how did I calculate tension? With respect to B, it moves away. With respect to A, it moves away from A. Okay. The same logic is applied here. So I take P2, the tension is acting upwards. Why it is upwards? Because it is moving away from the point of discussion. What is the point of discussion here? P2, or the object of discussion is P2. And how about T3? It is also going away from P2. Okay. Now how about M2? M2 you can see tension is acting upwards. It is. Why am I using T3? Because it is string 3. So the tension in string 3 is T3. Tension in string 2 is T2. Tension in string 1 is T1. As I have repeated again and again, that when you have a massless and frictionless string, the tension would be the same. Since string 1 is massless, it has a tension of T1. String 2 is also massless and frictionless, so it has a tension of T2. So string 3 is also massless and frictionless, so the tension is T3. Now how about M2? M2 is M2 into G. M2 into G is the weight of the object, and tension is T3. I hope you can get an idea what am I doing with free body diagram. You have a system. I take individually each system, each object in the system. What is each object in the system? P1, P2, M1, M2. There are 4 objects. I took individually each object. So what am I doing? Free body. I am freeing each body from the system and analyzing the force acting on it. And what are the force acting on here? There are tension forces, like tension, and you have the weight. So what are the forces acting on this each object? Either it is tension or either it is M. In this case only tension is there, tension force is there. In this case both tension and weight is there. I hope you are getting an idea. I will be doing more problems on it. I am giving a rough idea of what is free body diagram. So free body diagram is, I have a system, I have 4 objects, I segregate those 4 objects, then I am analyzing the forces acting on it. Okay, the next one that I am going to discuss is elastic spring force. Let's discuss elastic spring force. So I will draw an example. I will draw a figure to explain it. Let's take, I have a spring. This is connected. Okay, this is a equilibrium portion where I have a spring, A is equal to 0. It's an equilibrium portion. Now what I am trying to do is I am trying to extend it. Extend it towards this direction. Extend. So what happens? Let's take this is X. So when I am pulling it, when I am extending it, the force, the spring force shows a tendency to come back, that is F in this direction. In the same way, if I take this, if I compress it, what happens? The spring shows a tendency to regain its original position. So when I am compressing, I am moving in this direction. The spring force moves in the opposite direction. Similarly, when I am extending, the spring force goes in the opposite direction. So you can write this formula as F is equal to Kx. K depends on the length of the spring, like the material used, the radius of the spring, and all those things. So F is F spring, and generally we write as minus F Kx because it is in the opposite direction. So these are the forces that we discussed. Now we'll go to the next concept.